Okay. Yes. So good morning. Yes. Can you see the screen? I've shared the assembly drawing sheet onto the Solid software. Okay. So we are done this. We are done part one. That is the body of the screw jack, and then we are done also the nut of the screw jack. That is this particular part. Yes. Isn't it? Correct, no? And I've shown you this video how to do this. I'll just show you that. Right, this video I've shown how to prepare the drawing and the model in 3D environment, and also I told in this particular software wherever we have given threading option, it will be shaded with the green color portion. We cannot see the helix groove. Okay. Right. Okay. So which is the next part? Okay, the next part is the screw spindle. Okay, so first we will, that is part number 3, we will see the dimensions of this and how the part is going to be. Okay, so all right, so yes, they have given this particular drawing. So now when we look at the dimensions, onto this left hand side we have diameter 65. That means it's going to be a circular portion. From where is it? This larger diameter, from here to here. Okay, right. And then we have subsequently concentric to that another diameter of 22 mm, that is over here. So please always, whenever you have dimension, see the projection, I mean dimensioning line for that. Okay, where is it going? Okay, right. And inside that we have a thread of M12, okay, which is a standard thread, internal thread. Okay, M12, right. And here, okay, so for this hole that is to be made, this threaded portion, so they are given the details, right? So the threaded portion is for 30 mm, but the hole is for 35 mm. That means in the last 5 mm there is no threading. You can see that over here, right? Oh, you have a double line only here, only from here to here, but not beyond that. All right. So then, okay, so this overall, this particular shape that we have over here, this particular thing, okay, is totally for, from end to end, it is for 83 mm. Okay, from here till here, it is for 83 mm. The overall length is 240 mm. It's given over here. And coming to the other end of it, here it is going to be a diameter of 38 mm, and it's a square threaded portion, so by into 7 mm pitch. And yes, there is knurling over here, and here you can see the other things. The slope is for 10 mm by 45 degrees, and here it's a gap of for a length of 13 mm. So now what you need is that, okay, this axis line is, now we can write this axis line for 240 mm or a little bit more than that, right? And so totally, see, here also it is rectangle, here also it is here also it is cylindrical, here also it's cylindrical in shape, right? And all the posts, so it's going to be cylindrical one, okay, with a different cut cross section, okay, but on the whole it's circular, right? Okay, so now let's see how to do this particular part. Okay, so yes, so first we'll go to sketch. Okay, we'll go to sketch, we'll select solid part, any one of the plane, that is either the front view plane or the side view plane. We don't need to take the horizontal plane. If you take the horizontal plane, I think it will be better, because ultimately what is going to happen over here is that, I'll just show you that. So for this particular part, you can also draw it using the horizontal plane, because see, this screw jack, sorry, so CSK screw is going to come in horizontally, right? It's going to come in, sorry, I'm not talking about the CSK screw. We are talking about this particular portion, which is to be vertical. Sorry. In this case, we have to use only the front view plane or the side view plane. Sorry. That is the screw spindle. Yeah.
Sir, original orientation
Yeah,
where you join
original.
matters.
Yes, yes, it does matter.
Like you can't shift the, I mean the
Uh,
original plane while assembling the model.
you can rotate it. You can rotate it when you go to assembly mode. You can rotate it. You can rotate the part. There is option for that. Okay, but only thing is
But
we are
then,
trying to minimize the additional steps as much as possible.
okay.
If you select the right plane over here itself, then in the assembly you can
Mhm.
avoid unnecessarily rotating the part.
Yeah. Yes, sir.
So we'll draw one vertical line exactly onto the plane. Take it to the uh, middle and give the dimension as 240 length. Okay, that is the overall length of the part. So now we'll draw to the required uh, dimensions, if at all, if we know exactly, right, half of that. Yes, so we are drawing it exactly, right? So we are going to, it's going to be here, uh, see here it is offset by a distance, so it is 65. So we are drawing only on one side, 65 by 2, right? Right. So that is why 65 by 2, 32.5, there's an offset line and we connect it. Okay. And then, yes, so if you look at this, this overall length is 83 mm. Okay. 83 mm. That is why we have offset this horizontal line by 83 mm so that we can stop it exactly over there. So this line is at a distance of 32.5 from the middle. Okay.
So what is
So
it? Single and chain? I mean that option you're selecting, what does it do?
okay, if you use single, you can say whenever you touch any line or arc, only that particular portion will be chosen. When you put it under chain, all the other lines or arcs coming to, I mean, which is in contact will get selected. I'll just show you that. So, okay, so I'll just draw one. Right, now I want to offset this. Okay, I'll offset it by 10 Now when I choose single, okay, when I choose single, only this particular portion of the line I can select, I can click, I can go OK, and only this will happen. Right? Now, when I choose chain, just look at it, what is going to happen. Offset 10 mm, okay, chain, see what is going to happen. All the lines connected to it, everything will get selected. Can you see this?
Yes, sir.
Right? Okay. So we have to
So
be
then
careful with it.
entire figure
Whether we want
increases.
to offset the entire portion or only the portion that we are going to click, only one single line or an arc. Okay.
Okay. Yes, sir.
So here we have drawn to the distance, how much it is? 38 mm. So that means half of that is 19 mm. Okay. So that is why here you can see it is being drawn at 19 mm. Yes, the line has been offset for 19 mm, connected, and trim off the unwanted lines. So now if you see, it's almost correct to the cross section shape and size. We have to give only the chamfer. So we'll go to chamfer at 45 degrees. Set both the lines by 10 by 10 because they are given it in the drawing. 10 into 45. So what is that 10 into 45? So if I have a rectangle or a square or whatever it is, two adjoining lines, okay, when I give 10 by 45, what I'm going to do is that
The hypotenuse of the triangle should be 10, right?
so from here 10 mm from this particular corner, and again from this particular corner 10 mm will be left out. Okay, will be
So the sides become 10, not the hypotenuse
not
at
the
that time.
hypotenuse. No, this one will be 10 mm from this corner to here. It will be again 10 mm. That is the meaning of it. Is it clear? Okay, so we are from the corner, we will be away from it by 10 mm before that itself. Okay, and the angle over here will be 45 degrees. Okay, that is what is indicated over here, 10 into 45. Okay, and the same over onto the other side also, on all the four sides, on all the four corners. So yes, so this is a threaded portion. So here we can give 2 into 45 chamfer, which we have already done it in nuts and bolt. Now we have got the exact shape and size with the dimensioning also. Please keep the dimensions. Don't remove it. Always label the dimensions. It's easy to find out if you have made any mistake. Okay. Right. And now go to revolve protrusion. Select the part. Click on OK. Accept it. Now select the axis line, the center of rotation. That is this 240 mm vertical line, and go for revolve 360. Right. Okay. Now coming back to this, if we look at the drawing, the cylindrical portion has been done. The left out portion is only the thread that has to be formed over here onto this particular length over here, and this internal thread over here with the countersink. Okay, please see this thing. Look at it, it's not just a straight line over here, it is a line like this to fit the screw inside. So it is a hole drilled in this particular manner. Yeah, right. So this is called as a countersink hole. Okay, so we'll go to hole, threads, and go to hole, Okay, in the hole, first we'll create the countersink hole. We cannot create hole and thread in the one step. So first we'll create a hole. We need a countersink hole. Then we'll go to options over here on top left corner. Okay, the third over here. Once we click over there, we'll get this hole options. So here in settings, in the type it is as of now simple. That means only a straight hole that can be made. So in that, once we click the down arrow, we'll get the various options. We'll select countersink. Okay, threaded. Okay, fine. They're going in for thread first. Anyway, we can still do it. And yes, what is the thread dimensions? They have given it as M12. So we'll select that particular thing, M12 over here from the thread standard threads that is available. So M12 is here. Okay, and to what length? To finite length. So we have to select extend. We have 4 icons over here. The extreme right corner, once we click that, this whole depth option will be enabled, right? So I'll show you that. So just here extend. As of now, the whole depth is not enabled. Okay, we'll select the M12 thread. Yes, nothing is enabled till now. Whole depth is not enabled. Okay, so now we'll go to this and whole depth. How much have they given? They've given it for a length of 30 mm, right? Here it is. So we'll give 30 over here. Okay, 35. 1 second. Okay, thread and thread length. All right, fine. Actually, it should be for 30. Sorry, 1 second. 1 second, 1 second. No, the hole has been made for 35 mm, so that is why. This is for the whole depth, not for the thread length. This is for whole depth. And here, is it including the V angle or without V angle? So the dimension that they are showing in over here is up to here, not for this V angle portion. Okay, right? So that is extra. So we can choose that here. This dimension is only for the straight line, not for the V portion, right? We have to choose that particular thing. Angle will be 90 degrees. Now select the top surface, flat portion, and go to the center, click over there so that you can see these 2 lines that has been created. Then go to return and give finish on the in the bottom direction. Now you can see a light green, I mean a small green color portion that is present over here, which is the threaded portion that has been occurred. Okay. Yes. Yes. Any doubts till here? Any
No.
doubts? Right. Okay. So yes, now coming back to this, so we have found even this particular thing also, right? And the next thing is that this particular hole, which is at a distance of 35 mm over here from this particular line to the center of this hole is 35 mm. The diameter of the hole is 12 mm. Okay, the diameter of the hole is 12 mm. Okay. All right. Okay. So now what here, how we'll do this actually, now I'll tell you another new point over here. Yes. So here we have the cylindrical portion, right, over here. Okay, I'm talking about in this particular region. Right, this particular region is cylindrical in shape, and we want to have a hole that is to be made onto this curved surface, right? Since in cylindrical, the outer surface is curved, right? So actually what will happen is that we cannot, in any of the software, we cannot create a hole onto this particular place. So I'll just show you that. Okay, so I'll just choose a plane, sorry, sketch, plane. Right. So I'll return back. I'll go for revolve 360. And this one, go for this. Right. So now I have the cylindrical portion. Now I'll go to hole. I want to make a hole. Okay. So I just want to make a hole. I cannot go in any manner. See here, even if I go to hole, only plane will get selected, but not the object. It has to be either a flat surface or either the front view plane or top view plane or any of such planes only, but not this curved region. Just look at this. I cannot select this curved region at all, whereas I can select this flat region. Not a problem. Okay. Similarly, when I go to sketch and make a hole, one is now what I shown you is using the hole option. There it is not possible. The other one is that I have to draw a circle and make a hole. If I have to draw a circle, then I have to go to sketch, select either the plane or the flat surface from the part. But even now also I cannot select the curved region. That option is not there in any of the software. It does not allow. The software cannot determine that. Okay. So always when you make a hole like this, we have to either choose the flat surface from the part or a plane only. There is no other go. Okay. Right. So now to make this hole, okay, now just look at this. This hole is on a curved surface, but we cannot select a curved surface directly, but a hole has to be made. Okay, so we have to choose a plane. So in this case, this hole is actually, okay, from one end of this cylindrical surface to the other end of the cylindrical surface. Okay, so what they will do is that we will select this plane itself. So just look carefully. Okay, after this we will select any one of the vertical plane, either the front view plane or side view plane. So sketch. So see here we are selecting this particular plane except the horizontal plane, right? So now it zooms in automatically. Now we'll first fit it to the screen. Okay, then we'll go to a circle to draw a circle, or we can even go for hole. Okay, so here what I can do is we have taken a hole options. Diameter of the hole is 12 mm. Okay, yes. Now I'll select any one of the plane, either front view plane or side view plane. Yes, now I'll just put a mark exactly onto the vertical line over here. That is exactly at the center. You can see this red color vertical line. Yes, now zoom back, fit it. Okay, this hole has to be at a distance of 35 mm from this bottom line. From here, go to smart dimensions or dimensioning from this particular line to the center of this hole. See, from here till here, right? So this should be at a distance of 35. That is given in the drawing, right? Okay. Now we'll return back. Make a through hole. We want it on both the sides. Okay. We want it on both the sides. The hole should be made on this side also, onto the other side also. So here we have extend on both the sides or a through hole. Both options are there. So we can select that. I'll show you that over here. Okay, so from here, what I'll do is I'll go to hole, options, simple hole, diameter of 12 mm. Okay, I will select this particular plane. So it becomes like this. I'll just place it here exactly onto this vertical line, that is nothing but the center at some distance. Now what I'll do is, see, there is one more thing. If you get a dot with a square like this, that means it is fixed. Now I cannot move it. I'll just show you this one also. So now I'll go to smart dimensions. From here to the center of this, okay, it is 15.9. Okay, I'll just try to make it 20. It will not move. Why? Because I have fixed it over here, a square with a dot at the center of this circle. So that means it is fixed. I cannot move it. So you will get, even if you change the dimension, it will be with underline. Okay, that means it has not changed. Okay, so that has to be removed. Select on this, remove it. Right now you can shift the circle. Right, I have not drawn it for such a height. I'll just show you here. Sorry, why is it not moving? Okay. Right, like this. Okay, you should not get an underline below the dimension number at all. Okay, yes, we'll go back, and yes, okay, so it's like this, and I'll go to return, and I need this now. Actually, look at this hole is exactly at the center. I mean, on this plane, I want this hole to be extended on both the sides. So here I have extend to next, on both the sides. It's happened only one side, sorry. Yes. Right, through next. Yes. So the next thing is that we have to create a threaded portion onto this cylindrical length over here. Okay, so we'll go to hole, in that sub option threads, straight thread. Yeah, click on OK. Okay, right. Then select the cylindrical head, and then one end of it. Give M30 and click on finish. Okay, I'll just show you that one also here. I'll just draw one vertical line. This dimension, let me draw it, say for example for 100 mm. Okay, right. So now I'll go for the length of how much it is, 19 mm, because the radius is 38. Close this. Now with this, I'll return back, Go to revolve cutout, sorry, revolve protrusion. First, let me form the cylindrical portion. So it is like this. Okay, just like this. Now, after we form the threads, so now I'll go to hole in the sub options threads. Now it's a straight thread. That means the cylindrical portion is straight, not tapered. Okay, so straight. Click on OK. Right. Then go to thread options. Sorry. Then select. Just here. Click on cylinder to thread, which is the portion cylindrical portion to form the thread. This cylindrical portion. Click on this. Right, and then click the end of the cylinder from which threads has to be starting. So from here, from this edge, it has to start. Then I will get this option, type of thread over here. So click on this down arrow, M38. Okay, M38, and click on finish. Right. So this is how we this is how the threads has to be modeled onto the software.
Can you rotate it, sir, so that you can see the bottom?
Hmm. Okay. You have an edge, no? The circular portion, right? The circular edge that is present at the end of the cylinder, that has to be selected. So I'll repeat it. Okay, I'll just repeat this portion. So I've removed the thread. It's like this. So I'll go to hole. In hole, I have options. Another sub option thread. Thread. Click on OK. Then I'll select the cylindrical portion. Click on the cylindrical portion. Then the next step is click on this on the circle, the edge, the line. Okay, this at the end from where the thread has to start. So this is the place where the thread has to start from this portion, from this particular end of the cylinder. So click on that. Then I will get the options for which type of thread has to be uh, created onto the surface. So in this, click on the down arrow M38 and click on finish. So now this cylindrical portion will change to green color, right? Which means the thread has been formed. Is that clear? Okay, so we'll continue. So yes, as per the drawing, okay, all the things has been given. Now the thing is go to save, click on file, save. We'll get this option. Go to summary, title, give the name, give the name of the part, screw spindle project. Okay, document that number. In document number, give the part number. Okay, which is there in the bill of materials. In the drawing sheet, it has been mentioned. Okay, whatever is the part number in the bill of materials, give that as the document number. So number 3, screw spindle. Okay, so document number 3, project name screw jack. Then click on OK. Now go to, it will automatically come to save as. Go to your screw jack folder. Okay, file name should be the name of the part itself. Screw jack, sorry, screw spindle. Yes, material has also been given in the bill of materials. Screw spindle made up of iron 410W. Okay, Fe means iron. So in iron itself, we have different grades. Yes. Okay. So now we've seen part number 3. Then we'll go to part number 4, which is part number 4. Part number 4 is the cup. The cup is over here. Yes. Yes. Can you see this part number 4 onto the left hand side of the diagrams that is visible?
Yes, sir.
Yes. Okay. Now, how many views do you have over there?
2.
2. Yes. Can you name the views?
So, front sectional view and top view.
Yes, correct. Okay. So you have the front sectional view. Okay. This different sectional view, this particular portion, and there's a top view. Right? Right. So, okay. Now let us see whether it's rectangular, circular portion. What is it? So, yes. Okay. Yes. So the first thing over here, this particular length is for a distance of, sorry, is this one is for a dimensioning of diameter 45. That means it is a cylindrical portion. Okay. The height of this cup is 42 mm. Okay. The thickness of this cup at the bottom is 12 mm. Okay. Right. At the center, there's a hole which is for a diameter of 22.5. Yes, it's not. It's a cup. It's conical in shape. Okay, the inner diameter over here is going to be 38 mm. The thickness in this particular portion is 6 mm. Okay. Now, what is the diameter of this from here to here? What is the diameter?
45.
45. How do you say 45?
Sir, because if you draw the perpendicular lines to the bottom,
Okay.
it meets
Okay.
with the corner.
I'll extend it. Okay. Then what about this one?
So that is 6.
6.
Yeah, we just
6. No,
we
I'm
had
asking
12
what is this
to
distance from here to here?
uh, 57.
57. How do you say 57? Why not 55?
So on the section on both sides are 6. So 6 plus 6, 12, and with 12 we had 45. So because
See, look here in the top view.
okay, it says 65.
65. Okay. So the at the top end of the cup, it is for a distance of 65, and inside to that 65 minus, sorry, the diameter inside that is the thickness for 6 mm.
So it's not exactly perpendicular, the
No, no,
top to.
no.
Okay.
So don't.
53.
Hmm? Right. Okay.
Sorry, sir, lost you there.
Now, okay. So let's go to the videos. Let's see how. So it's all cylindrical.
Couldn't hear your last statement.
Okay, so it is not, see, this line does not mean, we cannot say always this corner will meet to the bottom corner. Okay, right?
Yes, sir.
From the top view, they're given the outermost diameter is 65. Okay, so again, everything is in diameter. That means a cylindrical portion. We can go for revolved protrusion. Okay, so this is part number 4, which is the cup. We'll go to solid part. We'll select the front view plane or the side view plane. So we'll draw one vertical line for a height of 42. If at all we want, we can draw this. We can offset it by a distance of 22.5. Why? How much is 22.5 into 2?
45.
45, right? Okay, here how much have they given? Diameter is 45. That means we are trying to draw the base of this. We offset the next one from the center by 65 by 2, because the outer diameter is larger diameter is 65, right? Half of that we'll offset that one also from the center. Yes. Yeah. Now we'll connect it up to 22.5, and from there, because this angle is not given, right? They have not given this angle. Yeah. Okay. They have not given what is this angle anywhere. Okay. Right. So but we should still be able to draw it. Now we can trim the unwanted lines. We will offset it by 6 mm, because the thickness of this cup is 6 mm. Connect it. And please look here at all these corners. Once it is correct, it has to be fixed, okay, with the smaller squares and all. Okay, right? Otherwise there is every chance that it can get disturbed whenever we do uh, any modifications or changes, or when we do any drawing somewhere else, it may get altered. Okay, right. And 11.5 we have offset it by 11.25, because at the base there's a hole of 22.5 diameter, half of that 11.25. So we'll offset there. And yes, the thickness of this at the base is 12 mm. So look here, from here the slant portion thickness is 6 mm. From the base it is 12 mm. They both meet over here in this particular place. Yes. And this. Yes. Now just look at it. Isn't it the one that we need? So what we are trying to do is that so what we have drawn over here is this particular portion. So here it's hollow. So we want this particular shape and this axis line, so that if we rotate this particular portion along this axis, we are going to get the cup. Okay, so we got that same shape with dimensions. We'll go to return, come back to 3D mode, revolve protrusion, select the part, accept it, then select the center of rotation, that is the axis, go for revolve 360. Right? Okay. Now, so look here, at the center there is still a hole that is present. Now the next thing is that we have to create this particular thing. What is it? We have to create this particular semicircle that is there on top of the cup, which is for a radius of 5 mm. Now how does it look? Where is it actually present onto this circular portion? So look here, this radius 5 mm semicircle is present on all the four sides which are perpendicular to each other, okay, or on the opposite side. So we have one 5 mm semicircle here, one more here, here and here, right? Okay. Now how to draw this, we will see that. So we'll go to front view first, okay, right? So I'll just show you here. After revolve 360, okay, now we'll go to sketch. Select the front view plane or side view plane, any one of them for the first step. Okay, now we are going to 2D mode. We'll select circle, diameter. Radius is 5 mm, so diameter is 10 mm. And we'll keep the center of the circle such that it meets the uh, top surface. Okay, exactly over there. And we'll come back, return. So look at it, it is exactly at the center because we choose the plane to draw the circle, right? So the
So
plane,
can you redo the last few steps?
yeah, from here,
Yeah.
okay, so sketch, select the plane, okay. Now we'll go to 2D mode, circle, diameter 10, keep the center of the circle exactly on this vertical line and onto this top surface of the cup. So click there, then return back, okay. Now the circle is on the plane, okay, not on the cup, because we choose the plane to draw the circle, okay. Now we'll go to cutout, select the circle, accept it, okay. Then give extend to both the sides, on both the sides, right, on both the sides. See here, extend, once we click here, it will get extended sides. So we get the semicircle cut on the cup, right? Finish it. Now go to sketch once again. We have drawn only two. We need the other two onto the other opposite side. So select the other plane. Okay. Last time we had chosen front view plane. Now you choose the side view plane and repeat the step once again. Same steps. Selection of the plane is only different. Right? Yeah. So the cup has been found. Save it. Summary. Title should be name of the part, which is called as cup. Okay. Right. So next we'll go to the next part. This is part number 4. And then we have part number 5. What is part number 5? Let us see. Which is the washer. Okay. So washer, where is part number 5? Washer is here. Okay, so look at this washer. Diameter is 35. Okay, there's a hole. Since it's a washer, there's a hole at the center whose smaller diameter is 14.5, and it's a countersink hole which has got a diameter of 25. The thickness of this washer is 8 mm. Okay. So washer will select it horizontal plane. Yes. Now we'll go to the thickness of the washer. Will go protrusion. Thickness of the washer is 8 mm. Okay. Finish. Now we'll go to hole, then options. Okay, type of the hole. We'll go to countersink. See, we get that same shape over here in the preview. Okay, countersink diameter. So here we have diameter, then we have countersink diameter, countersink angle. We'll fill up one by one all of them. Okay, so diameter. Just a second. Something is not done. Okay, countersink diameter 14.5. Why? What is that? Here it is, this smaller hole. Okay, 14.5. Then that's only the diameter. Countersink diameter is the bigger one. That is 25 mm, and angle should be 90 degrees. Click on OK. Take the top surface, the flat one, exactly at the center, give a click, return, you'll go to 3D mode and just click on the downward direction. Right? And then go to file, save as title, washer special. Okay, document number 5, project name screwjack. And part name should also be the name of the part, which is washer. Okay, and save it. Right? Okay. So this is how we create. All right. So the next thing is, after this part, we have part number 6. Yes, part number 6 is the CSK screw, right? Number 6, the CSK screw. It is here. Yes, so it's a screw. Overall length of the screw is 30 mm. Okay, right? At the screw head, the diameter is 24. The screw portion is for the M12. Okay, this countersink portion, we have different details. This countersink portion, that is this particular slant line, completely is for a length of 6 mm. And there's a small rectangular cut over here, which is for a depth of 3 mm. Now the width of this, that is this particular distance, is given over here in the top view. How much it is? 2 mm. Okay, it's a complete cut. You all have seen, you all have used a screwdriver to tighten the screw, right? That one. Okay, right. Okay, so we'll see how to make this particular one. So we'll go to 1 second. We'll go to solid part, select the front view plane. Draw the center of this screw, that is the axis for the required length, that is 30 mm. Then we'll draw the 1/2 of it, okay, which is for a length of 12 mm, that is the screw head portion. Onto the other end, it is for the smaller one. How much is that dimension? It is M12, right? That means it will be for 6 mm. Yes, for 6 mm. So here, what is the length of the screw? Overall, it is 30, counting the head also. Only the head portion is for 6 mm. So 30 minus 6 is 24. Draw a line for 24 mm and connect it to the end of the head line. Yeah. Now give the chamfer at the right hand side corner for 45 degrees. Set back A1, set back B should also be for 1 mm. Just click on both these lines and click inside. Return back, go to revolve protrusion, select the part and select the axis of rotation, give revolve 360. This is done. Okay, now we have to go for threading. So hold in that thread, select the cylindrical portion, select the edge of the circle, edge, that is a circle. Then you will get the type of thread that we want to choose. From the drawing, it is M12. So in the type of thread, we will choose M12 and click on finish. So now the only left out portion is this groove that has to be formed for a depth of 3 mm, width is 2 mm. Okay, so we'll draw that. So select the flat end of the screw, that is at the head. Okay, draw a rectangle. So first we'll include. Okay, first we'll do include. Offset, we can offset it by 1.5 mm. That's totally 2, no? Okay, so 1 mm on each side, right? 1 mm on each side. We'll include the circle. We can draw the circle. Instead of that, we can just click on, we can use this include so that that portion is redrawn once again exactly. Now we'll go to trim the unwanted edges. See now only just look at this blue color lines, only this rectangle is left out. That is what we want. The width is 2 mm. Click on return. Okay, now go to cutout for a depth of 3 mm. Select this rectangle. Okay. Depth of cut should be 3 mm below, inside. Right. That's it. So just look at it. Right, so this is the screw portion. Okay. Now the next thing is we will go for the last part, if I'm correct. What is that last part? Part number 7, which is the Tommy bar. Yeah. So Tommy bar is over here. Okay. So here, what have they given? Its overall length from here till here, it is 275 mm. Diameter at one end is 12 mm, the other end it is 20 mm, and this 12 mm extends for a length of 62, and the remaining portion is diameter 20, and the place where they meet, the angle is 45 degrees. Okay, knurling, of course, in this software we cannot do. Okay, so let's not worry about it. Okay, only this. So it's once again a cylindrical portion. I will see how to do that. The total length is 275. Okay, screw spindle, sorry, not the screw spindle, it's the Tommy bar. So yes, Tommy bar, we want it to be horizontally aligned, placed in the assembly. So we'll select a horizontal plane. Actually, that will be better. So overall length is 275. Then at one end it is 12 mm diameter, so 6 is the radius, and that is for a length of 62 mm. And then there's a line for 45 degrees. We'll just draw one line at 45 degrees, an inclined line. And from the other end of the 275 mm line, we'll draw one line for diameter was 20, if I'm correct. How much was the diameter over there? Yes, 20. So we'll draw a line for 10 mm. From there, draw a horizontal line until it meets the inclined line. Now trim the extra edges, give the dimensions. Right. Now go to revolve protrusion, select the part, axis, revolve 360. Okay. So that's it. The Tommy bar is also ready. Okay. So all the 7 parts that has been listed for this particular assembly has been prepared. Parts are ready as of now. Okay. We have to assemble. That will be the next step. That will be the next step. Yeah. Right. So yes. Yeah. So we have prepared all the 7 parts. Okay, and yes, so let us. Uh, I'll also share the drawing in the group now. Okay, uh, I want all of you to practice these parts on to create the 3D modeling. Okay, uh, also I will share these videos in the Google Classroom. Okay, and in the next class we will see for the assembly. Okay, but before that I want all of you to practice this. Okay, right. Okay, yes, answer attendance. uh, 1 second. Today's date is 16, right? Okay, yeah, all right. Okay, Madhu P. All right.
Yes, sir.
Okay, Paniraj is not coming. Motion.
Sir, yes, sir,
Mane
I'm there.
Paniraj, where were you, ma, for so many days?
Sir, I'll call you and
Huh?
tell you, sir.
No information, nothing.
Uh,
You have missed some.
no, I'll
Yeah,
call
yeah.
you
You
after the class.
without missing, you have to call me, right? Yeah.
Okay, sir.
Okay.
Okay, sir.
Motion, absent. Okay. Naman Shivananda. Naman. Okay. Srikanth. Srikanth is also.
Yes, sir.
Srikanth. Okay. Yes. Pavan Kalyan. Not there. Parthasarthi.
Present, sir.
Okay. Rahul Rathod.
Present, sir.
Okay. Rajat Patel.
Sir, present, sir.
Okay. Then Reni Sibbi. Not there. Absent. Rohan Unnikrishnan. He is also not there. Absent. Shreyas.
So present, sir.
What Shreyas? How many classes you have attended? Huh? So many classes you have missed in between.
I'll attend from now onwards, sir. There's some network issue near my home.
Okay. Right. Okay. Then Sai Lakshmi Shashank Varnasi.
He left the college,
Sir,
sir.
he left the college, sir.
Okay. So he left the college. Okay. All right. Samarth Nadik.
Present, sir. Present, sir.
Okay. Sayam Govardhan. Sayam Govardhan. Sayantan Banerjee.
Present, sir.
Okay. Shashank KS.
Yes, sir. Present, sir.
Shashank MV.
Present, sir.
Okay. Shivkumar Patel. Shivkumar Patel. Okay. He's not there. Absent. Sri Harsha Prasad. Sri Harsha Prasad absent. He is not there. Shubhankit Singh.
Present, sir.
Okay. All right. Okay. So one thing I want, see here. I want all of you to practice these drawings. See, I am doing it over here, but don't think that you have understood unless and until you practice. You will not be able to understand it properly, and you will also get the speed also. Okay, right? When you do it only, you will see the actual difficulty. Okay, where you are missing something or where you are unable to understand. Yes, what?
Will we be having the CAMD exam next week?
Not next week. I will announce it. Probably it may be there at the end of this month or in the first week of November. Okay.
Sir, can you ensure it is not between 22 to 26?
22 to 26. Okay, we'll see. It has not yet been decided. Why are you going out of station?
So no, sir. Durga Puja is there, so at that time I'll be a bit busy. So.
Oh, is it? Okay, okay, right. Okay, we have one meeting today. We'll discuss in that meeting and we'll let you know. Okay.
So please suggest to the people that
Okay.
keep with 22 and 26.
Okay. All right. Huh?
Thank you. Thank you.
Okay. Fine. Okay. So I
Sir,
will.
Naman present, sir.
Yes. Who?
Naman, 26.
Naman, ಎಲ್ಲಪ್ಪ ಹೋಗಿದೆ?
ಇಲ್ಲ ಇದ್ದೆ ಸರ್, it's getting disconnected, sir, before the attendance only.
ಲಾಸ್ಟ್ ಟೈಮ್ ಹಿಂಗೆ ಅಟೆಂಡೆನ್ಸ್ ತಗೊಳ್ಳುವಾಗ ಇರಲ್ಲ.
Sir, ಇರ್ತೀನಿ ಸರ್.
ಎಲ್ಲ ಇಲ್ಲಿ ಮಾರ್ಕ್ ಮಾಡಿ ಇಟ್ಟಿದ್ದೀನಿ. ಓಕೆ ಫೈನ್. ಓಕೆ ರೈಟ್ ಫೈನ್. ಓಕೆ ಐ ಶೇರ್ ದೀಸ್ ಡ್ರಾಯಿಂಗ್ಸ್. ದಟ್ ಇಸ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಶೀಟ್ ಐ ವಿಲ್ ಶೇರ್. Okay, I will share this sheet, this entire sheet in the WhatsApp group. Okay, please start preparing, please start practicing. And yes, I will tell you now only for the first test of CAMD, you will have part A and part B. That is the portions which has been already covered. That is section of solids, orthographic views, threads, nuts and bolts, okay, joints, that is knuckle joint and spigot joint. Okay, right, all these portions I have covered. Okay, these are the things that you'll have for your first test of CAMD. Okay, right, so please start practicing that one also. Okay, right. Okay, right. Okay, so we'll stop here for today. Thank you. Okay, I'll share this. So anyway, you have still time, so practice it. At least do one or two parts, any part from this drawing sheet, whichever is simpler or smaller part, start doing that. Okay, right.
Okay.
Thank you.
Thank you.
Thank you, sir.